You're watching the Aussie BIM Guru, and today we're going to be running through a tutorial in Dynamo for Revit dealing with numbering elements using a spline. Quite a common workflow if you haven't heard of it before. So splines, if you're not familiar with them, are a special line type in Revit, and they're set by control points and knots. So they let you basically keep clicking and generating new points, which generates the curvature of the spline. So they're very flexible and easy to draw in quite irregular shapes or paths. In this case, we're going to use it to look at room numbering. So essentially we're going to be using this to draw a spline, and we're going to base either the intersection or the proximity of a certain point related to that element to the spline itself in order to establish its number. And the way we're going to assess this is by using what's called the domain of a curve. So a curve from its start point to its end point respectively moves through 0 to 1 as its domain or its range. So we can assess how far along the domain each point occurs in order to establish an order of numbering. There's going to be no custom nodes used today, I believe, so it should be a nice easy script to follow along with. So the first method we're going to look at of two is by intersection. So essentially we're going to take the first point that a spline goes through in relation to an element, in this case a room boundary, in order to establish room numbering. This method's great for when you're dealing with something that actually the spline will definitely go through. So this might be something like a room or an area or a volume, something where you have confidence you're drawing through the element and you can get an intersection from it. So without further ado, let's just jump into Dynamo. So I've got a model here. This will be the second part that we'll go through, but the first part is essentially just a bunch of rooms. I want to number them like this. So I'm going to be looking at establishing a spline first as my reference, because we want to use something that the user can very easily set the order of, and a spline is the perfect tool. So we'll just start, and if you ever need to go around a really tight corner with a spline, just create a lot of control points, click a few times, and then you can just go through, and we're going to cross the corridor. And it's okay to go through the corridor again because we're already going to have intersected the corridor at that point. Because remember that a room's boundary is on all sides, so we're going to actually intersect the corridor here at its edge before we go into room 11, which we're going to be making room 2. Anyway, this will be our input. So let's just go back into Dynamo, and I'll just make a new script, and I'll do a save as, and I'll just call this demo 1. So let's get our spline. So to get our spline, we're going to do a select model element. And I'll just select my spline, which comes in as a model curve, or in this case a 2D curve. So I think it's a model curve still. So what we'll do first is go back and actually get our rooms first. So we're going to get all elements in our active view, because we're essentially going to be looking at only the elements we can see, because we're drawing a 2D spline in a view. So we're going to get the category of all those elements. There's obviously lots of ways you can get rooms in a view. You could just do select model elements. You could just do something much more simple. It may be better because all elements in active view can be quite slow sometimes because you might be collecting a lot of elements. But let's just in this case keep it simple. And we're going to convert this category to a string so that we can check if that string contains rooms. So we're going to do a string contains, and we're going to be searching this string for rooms, and we won't ignore case. So now we should be able to filter elements based on this. I'll just go to manual mode. But essentially we have a list of trues and falses, and we should be able to isolate just our rooms using this. So I'll get a Boolean mask or a filter by Boolean mask. And essentially our in list or our true list should just be our rooms now. So you can see we filtered out all our walls and car parks, and we can continue on with this element. So I'm just going to move these back a little bit again. So what we need to do now is assess our room. So what we're going to do is get its finish boundary. This is much easier than getting the room's geometry. So in this case, I always recommend you get the most basic piece of geometry you can of the element. I'm just going to set my geometry scaling to extra large as well and run. So at this point, we should see our rooms. And there's our room boundaries as Dynamo curves. So we're going to do a polycurve by joined curve. And the reason we're doing this is that all of our boundaries come in as sublists of every curve. But we want to find the intersection point on the polycurve, which represents all of those curves together. So now you can see, now we just have one polycurve per room. Much easier. What we're going to do now is get the curve here as well. So we're going to have to convert this to geometry in Dynamo. So we're going to get an element geometry node. And if we do that, now we'll see our spline as well, available as an input. And what we want to do with this is we want to put everything onto the same plane, because sometimes lines aren't quite on the same plane, or Dynamo has trouble assessing them on the same plane for an intersection test. So I recommend in this case that we use curve pull onto plane. And as this suggests, this will pull all elements down to a uniform plane. And in this case, the plane we're dealing with is the XY plane. So level at Z. So Z equals 0. So we're going to take this curve here, and we're also going to take all our other curves, or our polycurves, and just pull those down to the same plane, just to be sure that we're assessing them together. At this point, what we'll do is just flatten. We'll flatten the list of our polycurves, because they're all in sublists, which is a little bit messy. So we just want to have one polycurve per room. And there we go. So now we can see that they're just curves. And what we're going to do is intersect. And this will get the first intersection of one geometry with another. So of our spline, we're going to intersect each with our rooms. And we should get a point for each intersection. So what I might do at this point is just hide my room boundaries. And then we should be able to see our intersection points. And we can see a few points. It doesn't look like we have enough, so I might actually do a longest lacing, because I think we're not doing it to all of them. There we go. Now we can see we have intersection points. But note that some rooms we intersect them more than once, so it will get every intersection. We just want the first intersection as it occurs, the first point where that spline meets the room's boundary. So the first thing we'll do is we'll do a check whether there's an empty list, because sometimes you may have rooms that the spline doesn't go through. So I might actually just go and quickly create a room that isn't actually part of the spline, because we want to exclude those from our study, ideally. I'll just make a blank room over here that the spline is not going through. And I'll just rerun. And you'll see we'll end up with a list that's empty, which is basically our room that doesn't intersect. So we're checking if it's empty, and then we're going to filter by Boolean mask as well, just to filter out those particular rooms. So we'll filter out the intersection geometry. And we're also going to have to filter our rooms as well, because we only want to deal with the rooms that actually have a intersection in this case. So we're going to go all the way back and get our Boolean masked rooms. So now we should have two sublists. One contains the points as they intersect. I'll just cross-check. Looks like this may not be masking properly. I need to do a longest lacing, I believe. There we go. And that worked. So there we go. So now our out is going to be what we continue with. And likewise, our out will also be our successful rooms. So what we're going to do now is just get our first intersection point of each list. So we're going to work at level 2 in order to do this. So we're going to be working at the second level, which you can't see it here actually. I might just show you how this works separately. We're going to use a get item at index node. If I do get item at index 0, it will just give me the first sublist, which we don't want. So what we actually want to do is work at the next level up. So we're going to work at level 2. And this should give us the first item of every sublist. Interesting. Appears that doesn't... Oh, sorry, we need to work at the list, not the index. Sorry. The index is at the same level, but level 2 is the list we're dealing with. And now we get the first point of every list. So this is essentially the first intersection point as it occurs. So I can just turn off the preview of these intersections. And now we just get 1 point per room, so much easier. What we can do now is we can actually assess, we can do curve parameter at point, and we can assess how far along the domain we actually are at that point. And this is why it's really important to pull the curve onto plane, because this is our way of knowing that we're definitely dealing with a curve and a set of points that are coplanar. So of those points, we'll assess the domain. And what we should get is a number between 0 and 1 if we set it to longest lacing. There's a lot of nodes in this script that by default go to shortest lacing, so just be really careful with lacing. And there you go, and you can see obviously all these numbers are out of order at the moment because our rooms are also out of order. So what we need to do is run a list sort by key. I think by default it's in the order of their creation or their ID that they're sorted. And we're gonna sort our rooms in our out list back here by their parameter at point. Because the parameter at point is a number, it can be sorted. If I run that, we'll get our rooms, but what's important is you can see that now we're ordered by our domain. So our rooms are now occurring in the order that we want them to be. So now what we can do is actually just apply a numbering rule to these. So what I might do is give the user the ability to start above 1. So what I'll do is just count the number of items we have in our rooms. So we know our range of numbers we're going between. And then I might just create a code block. And I'm just going to say this is a starting number. And then it goes up to a starting number plus count take 1 with a spacing of 1. So now we can actually add a number to the front to make this number range go from a different starting point. So we'll just make this between 1 and 100 with a step of 1. If I go to automatic mode and I just change the output here, in fact I believe I might need to go to manual mode. I don't want to do C take 1. I can go to automatic mode. So you'll see at the moment it just goes from whichever number I tell it to start at, but it's always by the spacing of the number of our list count, because this is where we extracted this number from to insert into our formula to set the final value. So we can start from any number we want. So that gives us a lot of flexibility. What I'll do is just start us from 1 in this case. And what we'll do with that is we need to convert this to a string, because we're going to set a field that's text-based. The problem with numbers when you convert them to strings is that they typically gain a decimal. So we don't want to obviously name or number our rooms with this. So we need to go and actually get, in this case, we need to split our string. So we're going to split our strings based on the character full stop. And what this will leave us with is a sublist for each string, and it's found that first number before the decimal point. And what we can do now is we can also work at levels again, and we can do get item at index, and we can work at the second level again. There's other techniques you could use, but I'm just doing this so you learn levels as well. If we work at the second level of each of those sublists of strings for index 0, we should just be left with the number instead as a string. So that's again a really handy workflow with levels. And what we'll do is just give the user the ability to add a prefix as well. So we're just going to use a plus formula, and we're going to add a string. And if you were running through Dynamo Player, you could make this an input. You could also make your starting number an input as well. So if you right click on here and just rename this to starting number, that could be an input in Dynamo Player. And this could also be an input for prefix. You'd also want to make your model curve or your spline an input too. And we can just call that spline. So now the user has the ability to pick their spline, set their starting number, and add a prefix. In this case, let's just say we want to add r dot as our prefix. And we should end up with a list that pretty much adds that prefix onto the front. So strings are really easy to add together using the plus formula. Okay, so pretty much all we're left with now is just we have to set the parameter. So let's just set it to the number of the rooms in this case. So we're going to get a set parameter by name. And we're going to go back and get our rooms that are in the sorted order. And then our values will be our prefixed strings. And then we'll set ourselves to longest lacing just in case. I don't think we need to be at longest lacing. but just in case. And we could also make this an input, because this is going to be the parameter name. So we could just call this parameter to set. And we'll just call this number by default. So if I just minimize Dynamo, just so you can see the run button, and I run my script, you can see that now we've numbered in the order of our spline. So a really powerful little workflow. So that's the first part of the workflow, but we're going to look at a different workflow now as well that I find is also quite necessary. So the second method is similar, but instead we look at proximity. So we find the nearest point to an element's location or geometry on the curve instead. So it doesn't necessarily have to intersect with the curve. This is really common for things that their location is represented by a point. So in this case, we're going to be looking at parking spaces. So I'm going to keep my scripts that I currently set up, but I'm just going to do a save, and then I'm just going to save as, and I'll just call this one demo 2, because we're going to modify our script to suit a proximity method to curve instead. So let's just go look up at these parking spaces. So I want to number them around like this. At the moment, I've just added a multi-category tag to each of them, which is extracting the mark field. So if I just change this to 1, you can see my tag picks up 1. What we're going to do first, again, is create a spline. In this case, I'm not going to go through my parking spaces because I'm not actually going to get their geometry in a 3D aspect. So all I need to do is just make a spline that passes by the car spaces in the order that I want to number them. So what we're going to do is use this as our input instead. So I'm going to go back, and before I maximize Dynamo, I'm just going to go and get that spline instead. After this, I'm also going to take away the start of my script and just get a select model elements. And just to keep things easy, we'll just select all of our parking spaces we want to number. So we'll just do an isolate category, select model elements, and we'll just do a marquee over all of those parking spaces. So now we can maximize Dynamo. What I might do is just go to the end of my script and freeze it so that it doesn't set any values in Revit by accident, because we're going to be restructuring our script a little bit. Okay, so what we can do with this is instead of getting our finish boundary or our curves, we're going to instead get the location of these elements. So we're going to get element location. And we want to get this get existing elements location node. And in this case, this will be represented as a point. So you can see a point for all of our parking spaces, which is in the back corner. It's the family's origin, essentially. And you can see our spline that we're going to use to number them instead. Okay, so at this point, we're going to use a different method. So we're still going to pull our spline onto a curve, and we're just going to pull it onto the XY plane. We're going to get rid of our pull onto plane function here. And instead, and we're not going to be intersecting either, we're going to be using geometry closest to, should be called closest point to. So we want to find the closest point from the spline to our parking space location. And it will find the closest point upon that curve. We just have to set that to longest lacing again. And there you go. And now it will find the nearest point to each parking space. So essentially we can use this again to map the domain. If you want to be absolutely sure that these points are going to be coincident on the curve, again, we can set these to have a Z value of 0 quite easily. So what I'll do in this case is I'll actually set up just a little function to extract the X and the Y value. So I'm going to set up a code block, and I'm just going to say point.x location and point.y location. So location is just a variable in this case. And now we can get the X point and we can get the Y point of each of those locations on the curve. Now we can do a point by coordinates or X, Y, Z, and we'll feed in our X and our Y values, but we'll leave Z as 0. So by default, Z is 0. So now we know that the X, Y plane, which is Z of 0 as well, and the points will match. So we can proceed with these points instead with confidence. So at this point, pretty much what we can do. Actually, there's another way we could do this. We could actually do it the other way around. It's probably better to do it this way. So what I'd do instead is actually map the locations of the elements instead to the Z-plane. That way, if there's any sort of skewedness to the points versus the line, say some things are higher than others, it won't make any errors with finding the closest point. It'll just flatten them all into a plane, and then we can find the closest point. That's a better workflow. And that still works the same way, but now it assesses them purely on a flat plane when it finds the closest point. We'll use the closest point 2 from the curve pull onto plane. There we go. So at this point, we can just feed that into the parameter at point instead. And we don't need to worry about empty list checking because we're finding the closest point to the curve from everything. So technically every single element would have a closest point to that curve. None of them would trigger an empty list. So we can now just assess the parameter at each of those points. And again, we can sort by key. In this case, we're just going to go back and sort parking spaces. And we're really just following the same function from there. I think we're keeping everything else the same actually. So we'll keep our numbering and naming rules. The only difference is maybe we'll change our prefix to something that relates more to parking spaces. So in this case, let's set our prefix to C dash for a parking space number. And in this case, we'll just set the mark instead of the number. I'll unfreeze my set parameter value. If you're right before I do, I'll just make sure that everything's coming through. And there we go. We can see we've got 30 parking spaces and the numbering and naming rule seems to be working. So I'll unfreeze, minimize Dynamo. I'll just reset temporary hard isolate so I can see my tags. And I'll run. And there you go. You can see now it's numbered all of my parking spaces along the spline in the order that I've drawn my spline. So a really powerful and quick way to number things. I use this one for parking spaces and rooms all the time on big projects, especially the parking space method. This one's very useful and always highly requested. So that's pretty much it. So hopefully you find that a really useful workflow and find other applications for it in what you do. I just realized I've missed that, but I use Dynamo 2.0.3 in today's demonstration. You may want to use it as well or a similar build. But anyway, so thanks for watching today. I make videos about 2 to 3 times a week. If you've ever got any requests for topics, feel free to leave it down below, or just any queries about the topic I've covered. So thanks for watching today. And again, if you're not already following and subscribing, feel free to do so, and hopefully I'll see you in future videos.